Section 4.2, the periodic table. As more elements were discovered, it became necessary to organize them into some type of classification system. By the late 1800s, scientists recognized that certain elements looked alike and behaved much the same way. In 1872, a Russian chemist, Dmitry Mendeleev, arranged the 60 elements then known into groups with similar properties and placed them in order of increasing atomic masses. Today, this arrangement of 118 elements is known as the periodic table. Periods and groups. Each horizontal row in the periodic table is a period. The periods are counted from the top of the table as period 1 to period 7. The first period contains 2 elements, hydrogen and helium. The second period contains 8 elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. The third period contains 8 elements, beginning with sodium and ending with argon. The fourth period begins with potassium, the fifth period, which begins with rubidium, has 18 elements each. The sixth period, which begins with cesium, has 32 elements. The seventh period, as of today, contains 32 elements for a total of 118 elements. Each vertical column on the periodic table contains a group or family of elements that have similar properties. The elements in the first 2 columns on the left of the periodic table and the last 6 columns on the right are called representative elements. A group number is written at the top of each vertical column or group of the periodic table. For many years, the representative elements had group numbers 1A through 8A in the center of the periodic table, and the block elements known as the transition elements, which had group numbers followed by letter B. A newer system assigns numbers 1 through 18 of all groups moving alongside the periodic table. Both systems are currently in use, and they are both shown on the periodic table in this text and are included in our discussion of elements and group numbers. The 2 rows of 14 elements are called lanthanides and actinides, or the inner transition elements, which are part of periods 6 and 7, placed at the bottom of the periodic table to allow them to fit on the page. Names of groups. Several groups on the periodic table have special names. Group 1 elements, lithium, sodium, potassium, rubidium, cesium, and francium, are a family of elements known as the alkali metals. The elements within this group are soft, shiny metals that are good conductors of heat and electricity and have relatively low melting points. Alkali metals react vigorously with water to form white products when they combine with oxygen. Although hydrogen is at the top of group 1A, it is not an alkali metal and has very different properties than the rest of the elements in the group. Thus, hydrogen is not included with the alkali metals. The alkaline earth metals are found in group 2A. They include the elements beryllium, magnesium, calcium, strontium, barium, and radium. The alkaline earth metals are shiny metals like those in group 1A, but they are not as reactive. The halogens are found on the right side of the periodic table in group 7. They include the elements fluorine, chlorine, bromine, iodine, and astatine. The halogens, especially fluorine and chlorine, are highly reactive and form compounds with most of the elements. Metals, nonmetals, and metalloids. The heavy zigzag line on the periodic table separates the metals and the nonmetals. Except for hydrogen, the metals are on the left of the line and the nonmetals to the right. In general, most metals are shiny solids such as copper, gold, and silver. Metals can be shaped into wires, ductile, or hammered into flat sheets, malleable. Metals are good conductors of heat and electricity. They usually melt at higher temperatures than nonmetals. All of the metals are solids at room temperature except for mercury, which is a liquid. Nonmetals are not especially shiny, malleable, or ductile, and they're often poor conductors of heat and electricity. They typically have low melting points and low densities. Some examples of nonmetals are hydrogen, carbon, nitrogen, oxygen, chlorine, and sulfur. Except for aluminum, the elements located along the heavy zigzag line are metalloids. Boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, and astatine. Metalloids exhibit some properties that are typical of the metals and other properties that are characteristic of nonmetals. For example, metalloids are better conductors of heat and electricity than nonmetals, but not as good as the metals. The metalloids are semiconductors because they can be modified to function as conductors or insulators. Table 4.3 compares some characteristics of silver, a metal, with those of antimony, a metalloid, and sulfur, a nonmetal. Silver, shiny, extremely ductile, can be hammered into sheets, a good conductor of heat and electricity, used in coins, jewelry, and tableware. Density of 10.5 grams per milliliter and melting point at 962 Celsius. Antimony is a metalloid. It's blue-gray and shiny. It's brittle. It shatters when it's hammered. It's a poor conductor of heat and electricity. It's used to harden lead, color glass, and plastics. Its density is 10.6 grams per milliliter and its melting point is 630 Celsius. Sulfur is a nonmetal. It's dull, yellow, and brittle. Shatters when hammered. It's a poor conductor of heat and electricity, used in gunpowder, rubber, and fungicides. Density of 2.1 grams per milliliter and has a melting point of 113 Celsius.